Okay, moving on to part D. In order to determine the domain and range of f of g and g of f, Aaron found expressions for f of g of x and g of f of x and used his graphing calculator to sketch graphs of the composite functions. In other words, these two guys here. He obtained the following. Okay, this and this. And he concluded that for f of g, the domain was all real numbers and the range was all real numbers. So let's look. Is that correct? Yes, of course it is. It's a straight line at a slant, so it must cover all real numbers for both domain and range. G of f of x looks like this. Looks like it goes down as low as 1 right here. I'll just sketch that in. Not very well, but anyway, it's got crosses here by the looks of it at 1. So it's saying the domain, and the other thing is it looks like it goes -2 and +2. There's no values in between these two. So for domain, x is less than -2 or equal to -2. Yeah, that's that part there on the left. Or x is greater than 2 or equal to 2. That's this part on the right. Okay, so that's true. That works as well. And looks like y has to be 1 or more. Y is greater than or equal to 1. Don't worry about this stuff. It just means that the rest of the numbers are all real numbers. So let's see what it says down here. There are errors in Aaron's thinking. So in that case, there must be errors in my thinking. Okay, wonder what the errors must be. Well, he found the expressions for these two. Perhaps we should also. So, find expressions for these two. So let's do that. F of g of x. So that's f of g of x. So that's f of. Looking at our equations, if we have any. No, we don't have any. So we just have the graphs. Oh, wait a minute. Sorry, this is part D. We do have f of g. Okay, so at the top of the page there, if you look up, part A gives you the equations. G is the square root of x minus 1. Now applying the f function, notice it squares x and then subtracts 3. So, or squares the input value, which is going to be this for us, and then subtracts 3. So we've actually done this above. Squares that, subtracts 3. So there's our composite function for this. Let's look at the composition function for the reverse one. G of f of x. So we take our f of x, which is x squared minus 3, and now we apply our g function. So we've done all this above, and I probably should have just copied it down, but it's always good practice to do it again. Applying the g function, it means we square root, and x is replaced with, in this case, x squared minus 3. We still have that -1 under the square root sign. So there's our two composite functions. So let's look at the domain and range, which we've actually done already in part B and C above. And we can see that, well, no, we really just looked at the domain and range of f and g separately. So this is the composite functions. That's not just f of x. or g of x. We've got to consider the composite functions. Well, domain. Well, again, remember x here, this value under the square root sign has to be 0 or more. So if x is 1, it's 0. So x can be 1 or greater for this composite function. Greater or equal to 1. What does that mean for y, or for the composite function, for the output of the composite function for the y? So this is our domain. I'm going to put D for domain. And the range. Well, this value here, the lowest value it can be is 0 under the square root. So the square root of 0 is 0. Squaring 0 gives us 0. Take away 3. Looks like the lowest value we can get for this is negative 3. Any other value of x is going to make this positive, especially when it gets squared. So the range, in other words our y values, must be greater or equal to negative 3. Now how does that jive with what was set up? Here, f of g, he said it was all real numbers, so no, it's not quite the case. Okay. So I'm just checking what I have elsewhere in my answers, and okay, so that's domain and range. Let's look at this one, domain and range here. Any restrictions on our x value? Well, squaring it will make it positive, no matter whether it's negative or positive. The only trouble is that this whole value under the square root sign has got to be 0 or greater. So one way to tackle that is to say, okay, so x squared minus 3 bracket minus 1, this has got to be greater or equal to 0. So if we solve this for x, we'll find out what x has to be to make this greater or equal to 0. So I'm going to bring 1 to the other side, and we'll have x squared minus 3 greater or equal to positive 1. Bring the negative 3 over, x squared has got to be greater or equal to, adding 3 to both sides, 4. Now, what will make x squared greater or equal to 4? Now remember the one thing about squaring x values. If I have 2 in here, it will give us 4. If I have 3 in here, it will give me 9, so that's good. But what if I have negative 2? It will also give me 4. If I have negative 3, it will give me 9, and so on. However, negative 1 squared is 1. That's not going to work for this. That will only give me a value of 1 here. So it looks like values of negative 2 will work as long as it's negative 2 or less than negative 2. Less than and equal to negative 2. And as long as x is greater or equal to positive 2, we'll be able to get this greater or equal to 4. So this is our domain. And it looks like he got that right. What about the range for this? The range. Remember, this has got to be the square root. The whole thing has got to be greater than 0. Well, we have some restrictions on x. Maybe we should plug them in and see what other values we get out of here. If we have, say, negative 2 going in here will give us 4. 4 minus 3 is 1. 1 is, so this, yeah, that makes this 0. Okay, fair enough. So with these restrictions on the domain, we'll always get 0 or greater under here, which means that the composite function, when we square root a number that's 0 or greater, we're going to get a positive number. In other words, we're going to get an output number that is greater than 0. He put an answer here of greater than 1, which is not quite right. Why our composite function here is going to be greater or equal to 0. So that would be the range. This is the domain. Okay, so here it's saying, the second part of this is please graph these functions now that you know the restrictions. The two graphs above were wrong. So looking at restrictions that I just had up, it looks like we can only go as low in our range and domain. Got to think about that. So the graphs actually look 1, 2, 3 like from here at 1, -3 and up, crossing through 4, 0 and up. So there's no y value less than -3 and there's no x value less than 1. And in this one, he had the domain right, so it's 2 or greater from here and -2 or less, but Aaron's thinking said that the function, the range was 1 or greater, but we know it's actually 0 or greater, so it'll go off like this and so on. Okay, so I answered these questions in part 1 above. Okay, thanks for listening. That was a long lesson, and I will let you know in a moment what questions to do. Okay, so for the assignment, these are the questions I'd like you to do. Question 2, question 3, question 6. For question 7, do parts A and B only. Question 8, A and B only. Do question 9, 10, 12. For question 13, do part C only, and then do the rest, 14, 15, and 16. Okay, we'll see you in class.